Hey, good morning, eighth grade. I want to start off with an announcement real quick. I went to the Khan Academy and I went ahead and all the topics we've been doing are review. And so those are things that we had already done. And I know that, I don't know about you, but for me, I was, it didn't keep my excitement going, because we've done all these topics and I want to start something new because I know you guys are capable of it. Those of you who are showing up and doing your work and everything, I know that you have the mind and the dedication to be able to learn something new. So I went ahead and for eighth and for seventh grade, I went ahead and gave you a shorter list of assignments, but it's more things that we would have been doing if we were in school. So today's topic is something called systems of equations. All right, and so before we went home, we were working on graphing equations. So if you remember, we were graphing lines like begin with B, move with M, and we were graphing these lines all over the XY plane. Now, a system of equations, all a system of equations is when you have two equations or three equations plotted on one graph. That's all a system of equations is. It's when you have more than one equation graphed on the same grid. So today we're going to start talking about that. We're going to start talking about, so we're going to start off with a story about a troll and he collects money as people cross a bridge. And you're going to see that there's two equations that will happen in this story. And once we see those equations, we're going to try to figure out how to graph both of them and see what happens. So without further ado, I don't want to confuse anybody with extra details. There's a very good story about a troll, all right? So listen up. We'll listen to it together, all right? Here we go.
You're traveling in some type of strange fantasy land, and you're trying to get to the castle up here to save the princess or the prince or whomever you are trying to save. But to get there, you have to cross this river. You can't swim across it. It's a very rough river, so you have to cross this bridge. And so as you approach the bridge, this troll shows up. That's the troll. And he says, well, I'm a reasonable troll. You just have to pay $5. And when you look a little bit more carefully, you see that there actually was a sign there that says $5. $5 toll to cross the bridge. Now, unfortunately for you, you do not have any money in your pocket. And the troll says, well, you can't cross, but you say I need to really, really get to that castle. And so the troll says, well, I'll take some pity on you. Instead of paying the $5, I will give you a riddle. And the riddle is this, and now I'm speaking as the troll. I am a rich troll because I get to charge $5 from everyone who crosses the bridge.
Rich.
And actually, I only accept $5 or $10 bills. It's a bit of a riddle why they accept American currency in this fantasy land, but let's just take that as a given for now. So I only take $5 or $10 bills. I'm being the troll. Obviously, if you give me a 10, I'll give you 5 back. And I know, because I count my money on a daily basis, I like to save my money as the troll. I know that I have a total of 900 bills. So let me write that down. I have a total of 900 bills. Total of 900 $5 and $10 bills. Dollar bills. And he says, I will give you, because I'm very sympathetic, I'll give you another piece of information. He says, if you were to add up the value of all of my money, which is all in $5 and $10 bills, value of all the $5 and $10 bills that I have, I, speaking as a troll, bought dollar bills, is $5,500. This is a rich troll, is $5,500.
That is a rich troll. All right, just to recap, we got 900 mystery bills. We don't know how many of each we got, but we got $5,500. We're going to find out how many 5s and 10s we got, all right?
And so the riddle is exactly. And if you give the wrong answer, and if you're not able to solve it in 10 minutes, he's just going to push you into the river or do something horrible to you.
Oh my gosh.
He says exactly how many 5s and 10s do I, the troll,
Very good question.
have? So the first thing I'm going to have you think about is this even a solvable problem? Because it's not a solvable problem, you should probably run as fast as you can in the other direction.
True.
So now I will tell you, yes, it is a solvable problem. And let's start thinking about it a little bit algebraically. To do that, let's just set some variables. And I will set the variables to be what we're really trying to solve for. We're trying to solve for the number of $5 bills we have.
So I'm going to do this problem
and
too.
the number of $10 bills that we have. So let's just define some variables. I'll say f for 5. Let's let f equal the number of $5 bills.
Of
$5
fives.
$5 bills that we have. And I'll use the same idea. Let's let t is equal to the number of $10 bills that we have. Now, given this information, and now I'm not sure if I'm speaking as, well, let's say I'm still speaking as a troll. I'm a very sympathetic troll, and I'm going to give you hints. Given this information, setting these variables in this way, can I represent the clues in the riddle mathematically? So let's focus on the first clue. Can I represent this clue, that the total of 900 $5 and $10 bills, or can I represent that mathematically?
I think you can,
I have
yeah.
a total of 900 $5 and $10.
Oh, I like where he's
bills.
going.
Well, what's going to be our total of bills? It's going to be the number of fives that we have,
That's
which is
F.
F. The number of fives that we have is F. And then the number of tens that we have is T. The total number of fives plus the total number of tens, that's our total number of bills. So that's going to be equal to 900.
That's our first
so
equation.
This statement, this first clue in our riddle, can be written mathematically like this if
That's
we
very
defined
cool.
the variables like that. And I just set F for 5 because F for 5 and T for 10.
Makes
Now
sense.
let's look at the second clue. Can we represent this one? Can we represent this one mathematically, given these variable definitions that we created? Well, let's think separately about the value of the $5 bills and the value of the $10 bills. What's the value of all of the $5 bills?
5.
Well, each $5 bill is worth $5.
Yeah.
So it's going to be 5 times the number of $5 bills that we have. So if I have one $5 bill, it will be $5. If I have 100 $5 bills, that's going to be $500. Well, however many $5 bills, I just multiply it by 5. That's the value of the $5 bills. Let me write that down.
I'm going to guess the value of the tens is going to be 10
the $5
times how many $10 bills you have.
Now, same logic, what's the value of the $10 bills?
I knew it.
Well, the value of the $10 bills is just going to be 10 times however many bills I have. Value of the $10 bills. So what's going to be the total value of my bills? What's going to be the value of the $5 bills plus the value of the $10 bills? And he tells me what that total value is. It's $5,500. So if I add these two things, they're going to add up to be $5,500.
Yeah.
So the second statement we can represent mathematically with this second equation right over here. And what we essentially have right over here, we have two equations. Each of them have two unknowns. And just using one of these equations, we can't really figure out what F and T are. You can pick a bunch of different combinations that add up to 900 here. You could pick a bunch of different combinations where if you work out all the math, you get 5,500 here. So independently, these equations, you don't know what F and T are. But what we will see over the next several videos is that if you use both of this information, if you say that there's an F and a T that has to satisfy both of these equations, then you can find a solution. And this is called a system of equations.
Hooray.
This is a system of equations. Let me write that down. System of
I'll write it down too.
equations.
Okay. So here we have a system of equations. 2 equations. Let's hear him keep talking, alright? So this is the second video that you were assigned today.
Where we left off, we were trying our very best to get to the castle and save whomever we were needing to save. But we had to cross the bridge, and the troll gave us these clues because we had no money in our pocket. And if we don't solve his riddle, he's going to push us into the water. So we are under pressure. And at least we made some headway in the last video. We were able to represent his clues mathematically as a system of equations. What I want to do in this video is think about whether we can solve for this system of equations. And you will see that there are many ways of solving a system of equations. But this time I want to do it visually.
Yep.
At least in my mind, it helps really kind of get the intuition of what these things are saying. So let's draw some axes over here. Let's draw an f-axis, that's the number of 5s that I have, and let's draw a t-axis, that is the number of 10s I have. And let's say that this right over here is 500 10s, that is 1,000 10s. And let's say that this is, that's 500 5s, that's 1,000
Hold on.
5s.
This I'm gonna pause the video because I'm in the way of this man's graph.
500.
And I don't want to do that. I don't want to do that to y'all. So I'm gonna be even teeny tiny. All right, I'm a little guy now. Look at that. There we go. All right, let's get back into it though. I'm gonna rewind like 10 seconds because I am.
That is the point. The line 5s.
He drew that quick.
We have line right. No 10s. Then we're gonna have, that is the number of 10. You can solve for this system
here we
of
go.
equations, and you will see that there are many ways of solving a system of equations. But this time I want to do it visually, because at least in my mind, it helps really kind of get the intuition of what these things are saying. So let's draw some axes over here.
Fair enough.
Let's draw an f-axis, that's the number of 5s that I have, and let's draw a t-axis, that is the number of 10s I have.
This is like an
Let's
X and
say
Y
that
axis.
this right over here is 500 10s, that is 1,000 10s. And let's say that this is, that's 500 5s, that's 1,000 5s. This is 500 10s.
So he's counting by 500s,
and
okay.
This is 1,000 10s.
He's counting by 500s.
So let's think about all of the combinations of f's and t's that satisfy this first equation. If we have no 10s, then we're going to have 900 5s. So if we have no 10s, we're going to have 900 5s. So that looks like it's right about there. So that's the point. 0 10s, 900 5s. But what if it went the other way? If we have no 5s, we're going to have 900 10s. So that's going to be the point. 900 10s, 0 5s. So all the combinations of f's and t's that satisfy this are going to be on this line, are going to be on that line right over there. And I just draw a dotted line just because it's easier for me to draw it straight. So that represents all the f's and t's that satisfy the first constraint. Obviously, there's a bunch of them, so we don't know which is the one that is actually what the troll has. But lucky for us, we have a second constraint, this one right over here. So let's do the same thing. In this constraint, what happens if we have no 10s? If 10s are 0, then we have 5f is equal to 5,500. Let me do a little table here because this is a little bit more involved.
Yeah, 5f equals 5,500.
So for the second
5,500
equation,
divided by 5.
10s and 5s. If I have no 10s,
It's 1,100.
I have no 10s. I have 5f is equal to 5,500. F will be 1,100. I must have 1,100 5s. If I have no 5s, and this is 0, and I have 10t is equal to 5,500, that means I have 550 10s. So let's plot both of this point. T equals 0, f is 1,100, that's right about there. So that is 0, 1,100 is on the line that represents this equation. And that when f is 0, t is 550. So let's see, this is about, this would be 6.
Boom, I got it pretty spot on. Look at that.
9, so 550 is going to be
real
right
close to
over
500.
here. So that is the point. 550, comma 0. And all of these points, let me try to draw a straight line again. I can do a better job than that. So
He's doing this
all of
digitally.
these
That's pretty
points
tricky.
Are the points, let me try one more time.
He's got it.
One more time. We want to get this right. We don't want to get pushed into the water by the troll.
Exactly.
So there you go. That looks pretty good. So every point on this blue line represents an FT combination that satisfies the second constraint. So what is an F and T, or number of 5s and number of 10s, that satisfy both constraints?
Would it be this
Well, it would
point?
be a point that is sitting on
both
both
lines.
of the lines.
Yes.
And what is a point that is sitting on both of the lines?
That
Well, that's
one.
where they intersect. This point right over here is clearly on the blue line
And on the yellow line.
clearly on the yellow line.
Nice.
And what we can do is, if we drew this graph really, really, really precisely, we could see how many 5s that is and how many 10s that is. And if you look at it very precisely, and actually I encourage you to graph it very precisely and come up with how many 5s and how many 10s that is. Well, when we do it right over here, I'm going to eyeball it. If we look at it right over here, it looks like we have about 700 5s, and it looks like we have about 200 10s. And this is based on my really rough graph, but let's see if that worked. 700 plus 200, 700 plus 200 is equal to 900.
Okay.
And if I have 700 5s, 700, let me write this down. 5 times 700 is going to be the value of the 5s, which is $3,500. And then 10 plus 10 times 200, 10 times 200, which is $2,000. $2,000 is the value of the 10s, and if you add up the two values, you indeed get to $5,500. So this looks right, and so we can tell the troll, I know how many $5 and $10 bills you have. You have 700 $5 bills, and you have 200 $10 bills. The troll is impressed, and he lets you cross the bridge to be the hero or heroine of this fantasy adventure.
So, you see what he did there? He did his solution visually. What he did was he graphed both lines. So you see those two equations that we had that we were talking about, the f plus t equals 900 and 5f plus 10t equals 5500. He graphed both of them on the same axis, and he saw, oh man, there's an answer to both of these equations that is on both of the lines. So wherever the two lines cross, that's going to be the solution of your system of equations, is wherever the two lines cross. Now, I think we got really lucky, and our graph isn't even on graph paper. Maybe you picked up some graph paper, but I'm over here on a whiteboard. I don't even have graph paper near me right now. So we got really lucky that he did a pretty good graph, and then he estimated the 700 and the 200, and that was correct. Now, I want to show you something really cool before we move on to the next video. It's going to take like 10 seconds. Check this out. Check this out. So, I'm here on the graphing calculator website that I've shown you before, okay? As a matter of fact, I am going to shrink it a little bit. Let me shrink it a little bit so that way we can see what the heck is going on. So I'll shrink it even more. So here we got a graphing calculator, right? On the side, right above my head, is where the equations go, and on the right side is where the graph is going to show up. So let me just shrink that real quick, and let's enter both of these equations. Now, they used f and t, right? Let's see if that works. Because I know that they usually... Yeah, no. We're going to have to use x and y. So in our problem, the $5 bills were the y-axis, and the $10 bills were the x-axis. So let's do x plus y equals 900. So that's the total of the two bills. I got to zoom out because this is going to be... obviously, we're at a pretty huge graph. There we go. And then the second equation was, what was it? The tens were the x-axis, right? So I'm going to do 10 times x. And then the $5 bill values was $5 bills times y, how many $5 bills we had, equals the total amount of money. So there's both of our graphs. Same exact picture that, this is the same exact picture that Khan drew, and as a matter of fact, let's see ours. Ours looks pretty good too. I mean, we copied what Khan did, but like, it looks the exact same as what we have. So the cool thing is, this graphs it automatically perfectly if you go to Desmos.com. And check this out. If you go to this point, if you click on this point, it automatically pops up. If you click on the intersection point, it will tell you what that intersection point is. So I hope that you can see the 200, 700 there. So even though we're going to be graphing them by hand, you could always, I would love if you started using this automatic graphing calculator, because it'll graph things automatically for you, and it is so useful for you to learn how to do this. So anyway, let's move on with the next part of the con assignment. Let's hit testing the solutions.
Is negative 1 comma 7 a solution for the system of linear equations below? And they give us the first equation is x plus 2y is equal to 13. Second equation is 3x minus y is equal to negative 11. In order for negative 1 comma 7 to be a solution for the system, it needs to satisfy both equations. Or another way of thinking about it, x equals 7 and x is equal to negative 1. This is the x coordinate. X equals negative 1 and y is equal to 7 need to satisfy both of these equations in order for it to be a solution. So let's try it out. Let's try it out with the first equation. So we have x plus 2y is equal to 13. So if we're thinking about that, we're testing to see if when x is equal to negative 1 and y is equal to 7, will x plus 2y equal 13? So we have negative 1.
So he's doing the math
plus
now.
2 times 7.
I'll do it too.
Y should be 7. This needs to be equal to 13. And I'll put a question mark there because we don't know whether it does. So this is the same thing as negative 1 plus 2 times 7 plus 14. That does indeed equal 13. This is negative 1 plus 14. This is 13. So 13 does definitely equal 13. So this point, it does at least satisfy this first equation.
It works
this
for the first equation.
Does sit on the graph of this first equation, or on the
one.
line of this first equation. Now let's look at the second equation. I'll do that one in blue. We have 3 times negative 1. 3 times negative 1 minus y, so minus 7, needs to be equal to negative 11. And I'll put a question mark here because we don't know whether it's true or not. So let's see. We have 3 times negative 1 is negative 3. And then we have minus 7 needs to be equal to negative 11. I'll put the question mark there. Negative 3 minus 7, that's negative 10. So we get negative 10 equaling negative 11. No! Negative 10 does not equal a negative 11.
Correct.
So the x equaling negative 1 and y equaling 7 does not satisfy this second equation. So it does not sit on its graph. So this over here is not a solution for the system.
Easy.
So the answer is no. It satisfies the first equation, but it doesn't satisfy the second. In order to be a solution for the system, it has to satisfy both equations.
Awesome. Okay, so I'm going to hit this next practice assignment here. We're going to try this out by ourselves. So, it's the size of this window needs to constantly be changed, and that's okay. Okay, I think that's enough space there. So we got 2 equations, therefore we have a system of equations, all right? And we're going to check, is 1, 1 a solution of the system? So the y value is 1 and the x value is 1. So this one should be pretty quick to check. So let's write down the first equation, y equals 2x minus 1. Okay, the y value is 1 equals, and then we're going to have 2 times, well, what is the x value? That is 1 as well. And then subtract 1. Let's check if this equation is true. 1 equals, 2 times 1 is 2. 2 minus 1 is 1. So 1 equals 1. I'm going to put a check mark because the first equation was satisfied. That's what it means when it is true. It is satisfied. Okay, let us try the next one. 5 times the x value 1 minus 4 times the y value 1 equals 1. Let's see if this is true. 5 times 1 is 5. 4 times 1 is 4. 5 minus 4 indeed equals 1. So we put a check mark, and 1 comma 1 is a solution of this system of equations. So we're kind of doing 2 different things. We did like graphing style, and we're also learning how to check these solutions. So you take the numbers and you put them into the equations. Both equations were satisfied, so we're going to say yes. Yay. Next question. Next question. Another system of equations and another ordered pair to check. So the system of equations is negative x plus 4y equals negative 9, and y equals negative 2x plus 6. So you see both those equations above me. Dude, I gotta enlarge this real quick. I'm sorry. It's like I could barely see these things, you know? My old eyes. My old eyes cannot see these things. So, okay. I think, I think that works, right? Okay. I mean, I'm happy with that. Big old whiteboard. Boom. Okay, we're cooking now. All right. The ordered pair 2, 3. So let's do the first equation. The first equation says minus x. So the x value is 2. So we're going to do minus 2 plus 4 times the y value. The y value in this case was 3. And does that equal negative 9? Let's check. Negative 2, 4 times 3 is 12. So negative 2 plus 12, I know that equals positive 10. So does that equal negative 9? It does not. So we are going to, we could check if 2, 3 works for the second equation, but we already saw that it doesn't work for the first one. So is it going to be a solution of both of them? No, it won't be. I'm not even going to check the second one because the first one was obviously not true, so it's not going to work. Nice, huh? Okay, next one. We got 2x plus 7y equals 1, and y equals 4x minus 8. And we're going to check 4, 8. So 2 times the x value, 4, plus 7 times the y value, 8. Does that equal 1? Well, just looking at this equation, I'm already going to tell you I think that's not true, because this is a big positive number. You got 8, and then you got 7 times 8. What is that? 56? 8 plus 56, does that equal 1? No, not at all. So we know that the point 4, 8, that does not work for the first equation. It does. So if it works for the second equation, that's cool and everything, but it's got to satisfy both equations to be a solution of the system. So we're going to put no once again. Yay. And then final one. 5, 1 is the ordered pair we're going to check. And the equation is, well, negative 5y equals negative 5. Well, let's try the first equation. Negative 5 times the y value. The y value is the second number, that is 1. Does that equal negative 5? Negative 5 times 1 equals negative 5. Yeah, that's true. So put a big check mark by it. Next, let's check the second equation. 7 times the x value is 5, plus 6 times y value, which is 1. Does that equal 7? Well, 7 times 5 is 35. 6 times 1 is 6. 35 plus 6 does not equal 7. So we're going to put a frowny face there. And does 5, 1, is that a solution to both of these equations? No, not to both of them. So it's not a solution of the system. So we're going to put no once again. Hooray. Keep going, keep growing. I feel like a beast right now. Oh, you can see I got 4 out of 4 correct. All right, I feel like a beast right now, guys. Okay, so we practiced solutions of a system of equations. Let's try. So I'm gonna let you guys watch these 2 videos about systems of equations with graphing, but I'm just gonna go ahead and jump into the practice. Let's watch the video together.
So they say right over here, graph this system of equations and solve. And they give us 2 equations. This first one in blue, y is equal to 7/5 x minus 5, and then this 1 in green. Y is equal to 3/5 x minus 1. So let's graph each of these, and we'll do it in the corresponding color. So first, let's graph this first equation. So the first thing I see is that its y-intercept is negative 5.
So
or another way to think about it, when x is equal to 0,
he begins with
y
B.
is going to be negative 5.
Yep.
So let's try this out. So when x is equal to 0, y is going to be equal to negative 5.
Begin
So
with
that
B.
makes
Good,
sense.
good, good.
And then we see its slope is 7/5. This was conveniently placed in slope-intercept form for us.
Yup.
So it's rise over run. So for every time it moves 5 to the right, it's going to move 7 up. So if it moves 1, 2, 3, 4, 5 to the right, it's going to move 7 up. 1, 2, 3, 4, 5, 6, 7. So it'll get right over there. Another way you could have done it is you could have just tested out some values. You could have said, oh, when x is equal to 0, y is equal to negative 5.
So as you can see, he's...
When x is
I'm going to
equal
pause
to
this.
5, when x is equal to 5, 7/5 times 5 is 7, minus...
So he's graphing this the same way we were graphing this, all right? We're going to see what point where these lines intersect, all right?
2. So I think we've properly graphed this top one. Let's try this bottom one right over here. So we have negative, when x is equal to 0, y is equal to negative 1.
So he's
when
going to
x
begin
is
with
equal to
negative
0,
1. Good.
y is equal to negative 1.
And he's going to
And
rise
the slope
3, run 5.
is 3/5. So if we move over 5 to the right, we will move up 3. So we will go right over there. And it looks like they intersect right at that point. Right at the point x is equal to 5, y is equal to 2.
So that's how you...
So we'll type in x is equal to 5, y is equal to 2.
So this right here is how we graph lines. And as you can see, this is what we were doing last time. We graph 2 lines on one grid, and we see where they cross, all right? I'm going to jump into the practice real quick because I honestly think we're kind of ready, or at least we're kind of ready to learn from this instead of from the video. So let me make sure I got my whole picture here. So, oh, okay, cool. So check this out. We got 2 equations here. We got 2 equations. 2x plus 3y equals 6, and negative 4x plus 3y equals 12. All right. There's a couple ways we can graph these. All right. They give us a graph to graph that on right below. One way we could do it is solve this equation for y. So we're going to try to get y by itself. And if you get y by itself, you can then graph this pretty easily. Now, I'm tempted. I'm really tempted. And no, yeah, we'll do it. We'll just solve for it. I was going to say, I'm really tempted to use the graphing calculator so that I could just enter these equations as they are written into the equation. But no, we're just going to solve these. It's going to be quick. So 2x plus 3y equals 6. Write this down with me. We're going to try to get y by itself. So to get y by itself, you need to get rid of this 3 and this 2x. So we've been solving these equations before. What do you get rid of first, the coefficient or a constant that's being added? Even though this isn't really a constant, but it's being added. What do you get rid of first? You get rid of the 2x first, all right? How do you get rid of positive 2x? You get rid of it by subtracting 2x. So we did this before on one of our days. I just want to review it a little bit. Let's bring down what needs to be brought down. 2x minus 2x equals 0. So you bring down a 3y equals, and I'm going to bring down first the negative 2x, then the positive 6. Reason I do that is because I like to have my letter first. My x. I like to have this first because that's slope-intercept. Now how do I get rid of this 3? We're going to divide by 3 on everything. Okay? Let's see what we get. Y equals negative 2/3 x, and then 6/3, that equals 2. So this is the first equation we're going to graph. That's why I'm going to put a box around it, and I'm not going to erase it because we need it. Okay? Second equation we need is, I'm going to enlarge this because I can. Let's do minus 4x plus 3y equals 12. Now we're going to try to get y by itself yet again. So let's do the same steps we just did. How do I get rid of this minus 4x? What's the opposite of subtracting 4x? Well, you add 4x. And you do the same process. Negative 4x plus 4x equals 0. So we bring down a 3y. 3y equals, bring down the 4x first, then bring down the 12. And we're almost there. Can you please get rid of this 3 by dividing by 3? And I'm going to write my answer to this down here because that's where I have room. 3y divided by 3, that's just simply 1y. 4/3 is the slope, 4/3, x. And then 12/3 really is just 4. 12 divided by 3 is just 4. So those are our two equations, okay? I hope you can see them. And now we're going to go, I can't even talk. We're going to go to this graph that Khan Academy has nicely let us use. And let's graph the first one. Well, you're going to begin with b, which is 2. So let's go ahead and, I can't even find the graph. Begin with 2, and then the slope is going to be down 2, forward 3. Do you see that? We're going to begin with b, which is 2, and then we're going to go down 2, forward 3 from there. All right, let's try that. I'm going to take 1 point. I'm going to begin at 2. And then from that point, I'm going to go down 2, forward 3. And it makes the line for us. We don't even have to do like 3 points like we usually do. We just do our stuff. The next equation is y equals 4/3 plus 4. So this equation, begin with b, which is 4. And the slope is 4/3, which means we're going to move up 1, 2, 3, 4, and then forward 1. It looks like it's off the graph, so let me do this. I'm going to go down 4, back 3. Because I think that's the same thing as going up 4, forward 3, right? Yeah. So there we go. Because if I went up 4, forward 3 from this point right here, it wouldn't fit on the graph, so I had to go backwards. As you can see, there's a point of intersection. It doesn't quite land on a corner, but to me, it looks like, let me see, can you guys see that quite well? That point of intersection where the blue and the pink line meet, that looks like it's at -1, and then it's up almost 3. So is there an answer that is back 1? Ooh, so the B and C. Do you see how B and C both say x equals -1? Let's see how high that point of intersection go. Does that point make it all the way to 3? Does it? That point where the blue and pink line cross does not make it all the way to 3. So I believe it's going to be 2 2/3. Okay? Because it's definitely not on x equals 0. We definitely moved backwards 1 unit. So, hooray! Okay, so we're gonna keep graphing. Oh, thank goodness they gave us like this slope-intercept one, because these are easier to graph. In fact, I'm going to turn this over and just shrink it. Because now, let's graph our lines. They're already ready to graph. 2x plus 3 is the first one. So plus 3, that means we're going to begin with 3. And a slope of 2... What? How come this... Hold on. There we go. Begin with 3, and then the slope of 2 means you are going to rise 2, run forward 1. And that's the line. The other line also begins at 3, so let's put a big 3 point there. But the slope of the second equation is -3, which means -3 over 1. So let's go 1, 2, 3 units down, 1 unit forward. And it looks like that point right there, 0, 3, is, well, let's see, that point right there, that x is 0 and y is 3. And let's check if that's the point where both lines cross. Yes, it is. Alright. So for this next equation, Actually, I kind of want to show you this newish way. So, because I want to show you all the different ways. So you can take these equations and you can solve them for y yet again. That would be pretty easy to do. But I want to show you something that's even quicker, and I want to see if any of you like it. You're totally allowed to use this way. So the first equation says 21x plus 7y equals 42. 21x plus 7y equals 42. Let's go to Desmos.com and enter that. Desmos.com, man, I already forgot the equation. What was it? It was 21x plus 7y equals 42. 21x plus 7y equals 42. I gotta see, can you see my, oh, you can't even see where I wrote my equation. Let me shrink this. So there we go. You see what I've done? I literally just, all I did was enter the equation. That's all I did. I didn't have to do any math. I just typed in the variables and boom, the line automatically shows up. Okay, I gotta hide this whiteboard. What's the second equation? Because the second equation was also there. Minus 5x plus 5y equals 10. Oh, that one's gonna be easy. Minus 5x plus 5y equals 10. And they indeed cross. Do you see this blue and red line? So if you go to Desmos.com and you enter both of these equations, you will get the same graph that I have. And check this out. You go to the graph, you click that little corner point, it says 1, 3. That's our answer. You see how quick that was? So that's the magic of graphing calculators. You know, as long as you know how to use a graphing calculator, I am totally okay with you using it. All right. I'm gonna leave my graph picture just like this. I don't know if it's gonna count it correctly. I think it says, I think we're allowed to use the graph, but I think the answer that really counts is the numbers. So 1, 3, let's check it. Got it. Let's do 4. How many minutes have we done so far? Guys, oh wow, that's 41 minutes. Let's wrap it up here then. Let's wrap it up here. We'll do this final problem. And you know, this one, I'm still going to use the Desmos calculator because all the options are right here in the middle. I can't see. Oh, you know what? Here's what I'll do. That's what the blackboard is for. For this one, you could either use Desmos or you can graph it yourself on the tool. I'm just going to rewrite the equations so that I can see them, okay? So y equals negative 1 over 1x plus 2. And y equals 3 over 1x minus 4. Okay, so I just rewrote the equations so that I can just have a hope of seeing them when I graph them. Okay, I hope. Let me show them to you. There we go. Let's make it nice and big. There we go. And scooch it up. There we go. Okay, so there's both of our equations that I just wrote down. Let's graph them now. So first one is negative 1 over 1x plus 2. So begin with 2, and then the slope is down 1, forward 1. Second equation, 3 over 1x minus 4. So we're going to begin at negative 4. Negative 4. And then the slope is going to be 3 over 1. So we're going to go up 3, forward 1. And it looks like, I'm going to zoom in a little bit for you. It looks like that point of intersection of the blue and the red line, and I hope you can see it either on your graphing calculator or wherever you're graphing, it doesn't land on a whole number. In fact, it goes, I think to me it looks like it goes forward 1.5, and then it went up a half a unit. So that's what I think it is. I think it's 1.5 comma half. All right, so let's look at our options. Which one of these says x equals 1.5? Is it x equals half? No. X equals half? No. X equals 5 halves? Is that 1.5? 5 halves is 2.5. So no to C. And D is the only one that says 1.5 and then 1/2. So that's the one that matches perfectly. I'm going to hit check. Hooray. All right, that's all the work you had to do today, all right? We learned how to graph lines both lines on one grid and check where they cross. And we also learned how to check if an ordered pair is a solution of two equations. That's the two things that we did today. So thank you very much for sticking around, and be safe, be good. I'll talk to you later.